Okay, let me add Larissa here. Larissa. Got mine up to you. All right. So I just started the broadcast, and we'll go to our quiz, and we'll see if she gets on. And there's 40 something questions on here. 45.
Wow.
Let's each take, I don't know.
Like 10-ish.
We'll each take
10, 11. I guess 11. Yeah.
Yeah, 11.
Oh, 11. You're right.
All right.
Okay, so who wants to start?
I can start. Okay. So, in an article, I think I'm going to read these ones where we're trying to decide which one it is, so we can
Okay,
make sure we're
yeah.
thinking.
Yeah, I agree.
Okay, in the article of the Journal of Small Business Management, successful startup businesses in the U.S. and Korea were compared. So we know we have two groups that we're comparing. One set of data compared educational levels, but there's lots of them.
Mm-hmm.
People who manage startup companies, if you want to determine if the education levels are independent of the country. And since it says if they're independent or not, it's going to be the
Chi-square.
chi-square. I think he calls it chi-square.
Yeah, Kai.
But yes, chi-squared, except that's not what it's really called. Okay, we'll save that one. Number 3. Except there, slow. A human resource manager reported data from a recent involuntary reduction in force at her company. You're an attorney general. You want to determine if age discrimination was a factor. So they're going to report the number of employees in two groups. There's 40 years old or younger, and 40 years old or older, over 40. They also reported the number of employees in each group who were terminated. You want to determine if both groups were treated equally. So we have two populations. We have one thing that we're looking for. We're looking for if they're terminated. So it should be, because it's the same mean, it's going to be two populations, same mean, it's categorical. It should be two proportions, is what I believe.
Yeah, I believe it's just.
I think it's an independent sample t-test.
Really?
Oh.
And I think it's a test of two proportions.
Yeah, I think it's two proportions because it says you want to determine if both age groups were treated equally. So you cannot determine that with numbers. I think it's like, were you treated good or bad? Or
Oh, that's
So the difference between those two tests is whether or not it's categorical or quantitative.
yeah.
The quantitative would be like if you're testing results of drugs or something. That would be the independent samples.
Mm-hmm.
This is testing whether or not they were terminated. So I think it's a yes and no. But it's the number of employees who were terminated, but I still think it's a proportion, a yes and no, but I can't say for sure. We can do one of them and then go to the other one if we're wrong.
Yeah, I mean,
Let's take the
technically
test
they
of
didn't give us numbers, so it could be categorical. But if we were actually to do the test, like, we could get numbers.
Yeah, because you are dealing with
So it
ages,
could also be
whether
quantitative.
they're over 40 or under 40.
I know there was a test of two proportions done that we did once before where they talked about if people get polio versus they take the vaccine and they don't get polio.
Mm-hmm.
So for me, this is kind of similar.
Okay.
yeah, I agree. I think it's just the proportions that we can.
Okay, so we'll do number 4. The survey is conducted by a group of state lotteries. A random sample of 2406 adults completed the survey. Then 248 were classified as heavy players. Of these, 152 of the 248 were male. You want to determine if the proportion of male heavy lottery players is different than the proportion of males in the population, which is 48.5%. So for this one, we are looking at, I believe, a quantitative number.
Yeah, I think it's test of one proportion.
That's what I put.
I think it's a test of one proportion.
Okay.
Is that what everyone? Oh, sorry, this is categorical.
Yep.
But I did put one proportion on here, so,
Okay, yeah.
okay.
Yeah, because essentially that 0.85485 is they're giving us is the P that they're giving us. That's what I think
Mhm.
That's
that
right.
was.
Yeah.
Okay, number 5. The student project compared the effectiveness of 2 different combination locks. One turned clockwise, the other turned the other way. He asked 25 students to participate in the study, and they paid attention to the time it took them. This is going to be quantitative. They want to determine if one lock's easier to open. And so this one, I have a question mark, but I think it's a 2-sample t-test. What do you guys think?
I think
I think it's the paired
Pair
sample
sample, yeah.
t-test.
pair sample.
I said pair as well.
What,
Yeah.
what is, hold on.
This
What
is
is
this.
the
This
t-test?
is a paired one because they gave it the similar one that they did for one of our homework assignments was how to start a fire. They gave them a battery and lint, and then I think they gave them a stick or something, right? And it was a paired sample. So that's what I compare this to.
Oh, that's why I have a question mark, because I wasn't sure if it was that one or the paired. All right, so let me just put a star here just in case, but I'm going to say that we're going to go with paired.
Okay.
Paired. So, well, I guess the question is, are we comparing which one's faster, M1 equals M2, or are we comparing the difference of being 0 or not?
We're gonna essentially you would conventionally compare the difference because they're paired, right? We're gonna take the time that it would take to do the one lock and the time that it would take to do the other lock and find the difference.
Mm-hmm.
Yeah, yeah, you're right.
Okay.
Because if you choose one who is like the left, whichever way it turns, you have to choose another one that turns the opposite way.
If we're just
And they
doing
said
the
the
difference,
same
though,
person is
Yeah, and
doing.
it's the same person. Yeah.
Yeah,
If we're
that's the
doing
key. It's the same person.
if we're just doing the difference, though, it seems to me like you're not going to know which one is better, because you could have one kid that's easier one way averaging out with another kid that's easier another way, and
Well, and that's why at the end you find out which one really is
Mhm.
faster once you average all those.
you think it's paired then for sure. Okay,
Yeah.
let me make one more comment, just because there was also, when they compared the drug A to drug B, and they were doing the difference of drug A compared to drug B, that was an independent sample, 2-sample t-test. That was not.
But yeah, but the same person is not taking drug A and drug B. In this case, the same person is doing lock 1 and lock 2.
That makes sense for me then. Okay, so paired is same person. All right, agreed. All right.
We should talk this through though, because that's what we need to figure this out. So
I totally agree. All right. For the next 3 questions, identify one of the confidence intervals. So this is question 6. Okay, and a bank employee employs 2 appraisers. When approving borrowers for mortgages, it's imperative that the appraisers value the same types of properties consistently. To make sure this is the case, they evaluate 6 properties that both appraisers had recently valued. To make sure this, let's see, which confidence interval would be most appropriate. So I put that this would be the paired sample, but now I'm starting to second guess myself.
I put pair samples T confidence interval, but
yeah, because the house is the same, but then the 2 appraisers are differently. But then again, we can go find the difference between the 2 appraisers. And are they going to be equal,
I think because the houses are the
or
same.
are they not going to be equal?
But I think it's paired.
Yep. Okay, we're on paired, and then we're going to go to question 7. The Wall Street Journal article on satisfaction with career paths, the percentage of psychology majors reporting they were satisfied with their career path was reported. The same data was also reported for accounting majors. So we have 2 different things. You decide to construct an interval, which confidence interval, and I put, we know it's categorical, because it's satisfied or very satisfied. We know it's 2 groups, So I put that it's the two proportions.
Yeah, me too. Confidence interval for two proportions. Yeah,
Yeah.
that's what I wrote.
So why is it two proportions?
Well, there's two groups. You have accounting and you have psychology.
Oh, okay, got it. Mr. Accounting
also
and psychology. I was like, you're either satisfied or you're not satisfied. So yes, okay, sorry, missed that one.
Okay.
Okay.
Double stuffed Oreo cookies are supposed to have twice the filling. You and some friends decide to figure out if it's true. Take a sample of 55 Oreo cookies and measure how much fillings in each one. So for this one, you got it quantitative because you're trying to measure the amount of filling.
Mhm.
We don't know sigma, so sigma is unknown. So I put it's the one sample t test.
Confidence.
Yes. And I went back through and looked because we had that example in actually our book. So I went back to the book and found it, and it does match.
Oh,
I just have a question. I have per sample T confidence. Why is one if we are using two different cookies?
we're not using two. We're using 55 and taking all the stuffing out of all of them, and we're taking all the stuffing out of regular Oreos for it. And aren't we?
No, technically we're not taking or stuffing out of the single Oreos. You're just focusing on the double stuff, is my understanding of that.
Okay.
Let me check. I'm supposed to have twice.
Well, I guess it doesn't tell us. It doesn't tell us how much is in regular Oreos right now, but all we're focusing on is the confidence
double stuff.
material for the double stuffed Oreos.
Oh,
Yes.
in order to compare it. Oh, okay. So they are just saying that we want that so we can compare with regular. But we
Yeah.
are not doing the comparison right now.
No. Okay,
So,
then
so you put one sample T confidence interval?
yeah.
One
Yes.
sample T, yeah.
Okay. That was confusing for
Question
me.
9. Which of the following describes the notion of the significant level of a hypothesis test? I could be wrong on this one. I put B, the probability. Oh, just kidding. It's different on here. They're in.
Oh, yeah, it is. They're switched. That threw me off.
Yeah, so which one did you put?
The probability of observing a sample statistic more extreme than the one actually obtained. Is that what you guys have?
That is
Okay,
what-
so
No, because that's a p-value. Let me
I
check.
didn't.
the question, we're on question 9, right?
Yeah.
Yes.
And we're talking about the level of significance of a hypothesis test, right?
Yeah.
Yes.
The level of significance is the probability of committing a type 1 error.
Are you positive? Because I didn't know that.
Oh,
Yes.
and then the P
I looked it up,
value is-
yeah, like I said, I was going through all my notes this morning,
Okay, let me write this
and that
down.
was one of the,
Okay.
So does that
Oh,
mean the P value is the other one, the probability of observing a sample statistic?
so then the p-value, the next one,
Is
is the probability of observing a sample statistic more extreme than the one actually obtained, assuming the null hypothesis is true.
okay, so the significance of
Okay, back up to the first one. So the level of significance, so I drew the little symbol for that, is the probability of committing a type 1 error.
I'm so glad you
Okay.
know
And then-
that for sure, because those two I get confused.
I honestly,
And then the
when I
second-
originally did this, I did get it confused, and then I put arrows and say I had them swapped.
Oh, okay.
Which one of the following is the advice about the probability of observing the more extreme ones? So, p-value.
Yes. So that's the p-value. Okay, the long one.
Okay, this question 11,
Yeah.
this one kind of gets me every time. Like, I don't know.
I went back to because there was that one homework assignment, and it is true. This 95% of 95% confidence
Yeah.
inner actually contain the truth is correct, and it just doesn't make sense to me.
Yeah, that's what I put.
That is the right answer?
That is the right answer, I believe.
Okay.
It's the right answer for one of our.
Yeah, but I get confused with that. Like, what does every time they ask, what does that
It
exactly
just doesn't
mean?
make sense in my head. It just I don't know why. I can't
I mean, like,
wrap my brain.
I don't know,
around it.
like,
'Cause to me, it would make sense that it would be the last one, right?
Yeah, that could be the one. Yeah, I got those two because I know that those two are right, but I don't know if this is the case that they are right. Like,
I didn't know if it was the second one or if it was the last one. That's why I was like,
yeah, I got the two answers because those are like those are right. Like those answers are right, but I don't know if those
I didn't
are right.
know.
I
Like,
know it only lets us select one. Both of them I feel are right.
that's exactly my thought. And so I was like, well, I'll just ask them. Maybe they'll know.
Yeah, me too.
Oh, you know what the problem is with the last one?
Yeah.
The problem is it says there is
it's a
a
chance.
95% chance, and it should say we are
Yeah.
95% confident.
No.
Saying that it's the other one.
Okay, that makes
I,
sense.
I have a question. It was number one, the one that I had. Numbers 95% of the sample means are between 10 and 20. Is this ever right? Like in other cases, or?
I want to say no, because it's all supposed to about how our confidence. If it doesn't have the word confidence in it, then
Oh,
it's
okay.
not
Usually-
answered.
Okay.
Whoever does number 12, I had no idea how to do it. I just forgot.
Okay, I think number 12 is just
Teach me how to
30. I don't know for sure, but
It's
I
30.
have it. Got it. It is. Yeah, I know. You would think it was
Well-
something way overly complicated.
No, sorry, it's not 12. It's 13 that I don't know how to do.
oh,
Okay.
I think that's the one where it's like the squared root of p times 1 minus p over n. I think.
Yeah, but let's answer 12.
Say that again, square root of p.
It's this whole equation I'm about to say is underneath the square root. So p and then times in parentheses 1 minus p over n.
Divided by n.
And
Yeah, sorry, divided by n.
In the whole thing, including the n, is in the
In the square root sign, yeah.
so that's the standard deviation of the distribution of the sample proportion.
Yeah. I was
Okay.
doing it and I was like, I really think this is right and I really hope it's right.
Me too.
So the answer, did you get 0.046, Charity?
Yep, I got that.
This was 13.
Okay, but we haven't given the answer of 12. So 12 is 0.3?
30.
Zero.
It's-
Yeah.
Yeah, I got
It
0.30.
should be
Oh, I thought it was 30.
No.
No, I think
0.30.
it's 0.30.
Because it's 30%, but rather than saying 30%, we're going to do 0.30 or 0.30.
Okay, if you want, I can take the next.
What Charity's doing, we'll let Charity go.
Oh,
Okay.
okay.
She's already done the
Okay.
last next two. So.
What is the standard deviation of the distribution of the sample proportions? Let's see what I put. Is that number 12 on the thing right now?
Yes.
Yes, yeah,
Okay.
that's the one we just talked
I
about.
put down 0.458.
Yes, so 0.46.
Wait, what?
Because we rounded the three, because we should round it to the 3 decimal points like they have everything rounded to.
0.046.
Yes.
Uh-huh.
Oh, I know. I got the one that says 0.458, like no zero in front of it. Hold on. Let me try this again.
Let me put it in my calculator too, because
Yeah.
I do that one.
Yeah, I was confused, but probably you just obviously 0 because it's the same 458, but you can do it.
Minus 0.30
Okay. Give me just a
divided by. Oh. Well, I'm pretty sure that I did get the correct answer and I just didn't include the 0. So yeah, equals 0.
Yeah, that happened to me.
Okay. That was tricky though, because I felt like they did that a couple times where they added the 0 or
Yeah,
took
they
it away.
added the 0 and
was
took
the
it away.
same.
And I just,
Yeah.
Mhm. I was like,
0.045. Yep, I got it. Okay.
great.
okay, now this one I was kind of questioning.
Okay, go ahead.
What is the probability that your random sample of 100 adults will have a sample proportion less than 0.25? So is this when we're going to put it in the probability applet?
I did.
That's what I thought.
Now, do we put the 0.25 or am I putting the 0.046?
No, I think you have to do the C value for the C score first, and then with all the formula, and then with that result, then you put it in the applet, and then you get the result.
Okay, that makes sense. So I need to do
The formula is P
this
hat
for myself.
minus P divided the previous formula you gave.
Oh, okay.
Tell me the formula. because I didn't get this.
It's p hat minus p divided square root of p times 1 minus p divided n.
So it's like
Sorry.
the formula I just
I don't know if I'm using the right word. Probably someone else can say it.
Hang on.
All right, sorry, I don't understand. It's the whole thing square rooted or no?
Yells it down, like,
Okay.
you can do it, like, someone else can say it.
Keeling, what's the formula?
The formula, hang on, let's do this. Where are you? Where are you?
Charity gave you the part that is under it. It's p hat minus p.
Okay, really quick, I'm doing a screen share right here. And I gotta see if I can find the actual formula because I put this all in so it shows, it kind of calculates it automatically. So if I put in my 0.25 and my 0.3 and my 1, it automatically calculates my z-score for me. So you're supposed to take, let's see, it says K8 minus K9, which is, so you take the p hat, which is the 0.25 that they give us, minus the p, which is 0.30, and then you divide that by the square root of the 0.30 times the 1 minus 0.30 divided by the population.
So that's a 0.46.
0.46, right?
That's the standard deviation, right?
Yeah, that's the answer you get at the end.
No, but that's how we get, that's
Sorry,
the z-score.
What was p hat?
So the p hat is what they're giving you, the 0.25, right?
0.25.
Yeah, now it's trying to tell you if it was less than this 0.25.
I don't know why these.
And
I normally write down
the left side, right?
Yeah, you just highlight the left side.
I'm glad I can keep track of something.
So 0.25 minus 0.3. This gives us a z-score or?
It gives you the z-score.
Z-score, yeah.
0.46. So the z-score is negative 1.08.
0.910894.
Wait, say that again, Monica.
Minus 1.091084. That's the z-score.
So you can only put in the z-score the negative 1.091.
Yeah.
Right? And then you take that number and we're going to put it in the applet.
And highlight the left side?
Just the left, that lower side. And so what did you guys get there as a p-value?
I got 0.138.
Yeah, me too.
Perfect. Good.
Negative 1.091. I'm not going to do well on the test for this part. I skipped it because I don't have time. I have to take the test as soon as we're done. All right. So.
Oh my goodness. That just stresses me out. That stresses me.
0.138, right?
So yes,
Yes.
0.138 should be our answer.
Okay. Are you ready to go on?
Yep.
All
Okay.
right, keep going, Charity.
Acupril is meant to control hypertension. In clinical trials of Acupril, 242 subjects were divided into two groups. The 1,563 subjects in the experimental group received Acupril. The 579 subjects in the control group received a placebo. Of the 1,563 in the experimental group, 61 experienced dizziness as a side effect. Of the 579 subjects in the control group, 15 experienced dizziness as a side effect. Let P1 be the true proportion of people who experienced dizziness while taking Acupril. Let P2 be the true proportion of people who experienced dizziness but did not take Acupril. Create a 95% confidence interval for P1 minus P2. Input the margin of error, lower and upper bounds below rounded to 3 decimal places. So, oh, they added a margin of error. Okay, let me do that then.
I don't know how to do the margin of error.
Is that
I
the
get
one
this
where
wrong.
we subtract the two, like, confidence numbers.
You got
and then
it. You
divide by
take
two.
the lower confidence interval and the upper confidence interval and divide them by 2.
Okay.
And I
so-
did
So
that
real
on
quick, you're going to go to the,
And I did it like 3 times and I got it wrong. And I thought I did that for both of them. I mean, I did
Did
it
you
over and
guys-
over again and I couldn't figure it out.
Did you guys get the 0.003 and 0.029?
Yes.
yes.
Okay, cool. Just making sure.
Yeah, if I were to, it's, and the one is a negative 0.003, right?
Yeah.
Yeah.
Can someone teach me how to use my calculator? Maybe that's the problem because it just says error every time I try and
I don't
Or
know.
teach me how to do it in Excel. Just tell me how to do it in Excel. I'll do
Okay,
it in
so
Excel.
just to do in Excel, all right, did you have the confidence intervals right there, right? Okay, so what you're going to
Is this-
do, are you
wait.
ready?
One question real quick. When you find the margin of error for a 95% confidence interval, which test are you doing that for?
Okay, so we're in the 2 proportions. Okay, go to your 2 proportions tab and make
Okay.
sure that your X1 is the 61 and N1 is 1563 and then X2 is 15
Yes, yep,
and
I have all
N2
that.
is 57. Okay, so you got a confidence interval right now of negative 00299, correct?
Confidence interval of
Negative 0.00299 is the lower
Well-
bound.
it says 003, but
Yes, if you were to round it, I kind of sticked it out. So if you were to round it, it was 003. Okay, so what you're going to do is go down to like a cell just below that that's empty.
Yep.
Push equals. And then open parentheses.
it equals.
And then you're,
Yep.
okay, and then you're going to click F21, which is your lower bound confidence interval.
Well, it's not.
Oh, sorry, F21 is your upper bound. Either way it works, upper
Okay.
bound or lower bound.
I'll do the lower bound first. Okay, I clicked it.
You did the lower bound first, and now click minus
Minus.
the other one, the upper bound.
Okay.
Close your parentheses.
Yep.
Divided by, and then put the number 2 in and hit enter.
Okay, so negative 0.01611 or whatever, but
But it can't be negative, right? So we drop
You got
Yeah.
it. So we know it can't be negative, so you automatically turn it positive. And if you're nervous about that, all you have to do is do the next cell over and do the exact same equation, just flip it. Do the upper bound minus the lower bound divided by 2. It just gives me a warm, fuzzy feeling inside when they match.
okay, so actually, can't we just do like isn't there like a,
There is a formula, but every single time we did the formula, it came out wrong, and I don't know why.
Yeah.
to just make it positive? No, to make it positive.
No, yeah, and the
Positive.
formula is really long.
Arrow is always positive.
Yeah. And the real formula is really, really long. So it's better.
Okay, let me type that in there. So 0.016.
Mm-hmm. All right, and then 16, input the lower bound. I got negative 0.003.
Yep.
And then,
Wait, it was negative, right?
yeah. And then upper bound, 0.029.
0.0, yep.
All right, and then 18, perform a hypothesis test to see if the proportion of experimental group subjects who experiences dizziness is different than the proportion of control group subjects who do. Use a level significance of 0.05. What are the appropriate null and alternative hypothesis? I did the first one where they're equal, and then the second one where they're not equal.
Yeah, me too.
So the first option.
Okay.
19, the value of your test statistic is, hold on, let me get down there. 1.458.
Yep.
Okay. And then 20, p-value of your test, I put 0.145.
Mm-hmm.
And then 21. So is there sufficient evidence to conclude that the true proportion of people who experience dizziness while taking Acupril is different than the true proportion of those of people who experience dizziness while not taking Acupril. I said no. I failed to reject HO.
Yeah, me too.
Null
Last
hypothesis.
The last one.
Okay, perfect. Then you.
Should we go ahead and trade now since we're going into a new subject?
Okay.
Monica, you want to go or do you want me to go?
No, I can go. Okay. So it says, a survey was conducted of 1,279 randomly selected adults aged 18 and older. They were asked, are you a morning person or a night person? The hypotheses for these studies are, being a morning or evening person is independent of age, and the one being a morning or evening person is not independent of age. The results of the survey are given here. We have conduct a test of independence. Use a level of significance of 0.05. So question 22, calculate the test statistic for the hypothesis test. Assume the requirements for the test are satisfied. So 22, test statistic. Oh, let me open the, I don't know what number was that one.
It was on the exam. It should have been question 19.
Oh, so I got 6.579.
Yes.
Yeah, 6 point, yeah.
Oh,
5.8.
6.580, yeah.
Yeah, and so that's why I don't know whether we should round it because I'm not
I don't know either.
Yeah, I don't
think
know
we'll
what
leave
they
it. I bet you they're gonna let it both be right because to me that makes more sense. But
Yeah, I agree.
Okay. Calculate the p-value for this hypothesis test. Assume the requirements for the test are satisfied. So I got 0.087.
Yep. So did you say that you're keeping 6.580 for the previous one?
Yeah.
I'm doing 6.579.
Oh, you did?
Because that would be the correct way to do it and round it if we're going to the 3 decimal points. The 579.
All right.
Well, if you think about it, hold on, let's see. So we can move the decimal over.
But if they gave the answer like 580, I think.
I know that's the confusing thing, right? On the thing, on the warm up, they gave an answer of 6.580 and not 579. So I'll put 579 and I'll submit first. If I'm wrong, then I'm wrong.
If you go on Excel, you can move the decimal over another space to see what the other number is. So if you do that, it's a 9, which means we're supposed to round up.
Ah, way to go, Charity. Okay, so we'll deal with, let me go change it then to the 580.
Okay.
Okay.
That would be why they did that one. Okay, thank you for explaining, Charity.
Mm-hmm.
But I didn't get the explanation. What was that? The Excel
So if
thing?
you go in Excel and click on where it has the test statistic, the 6.579,
Yep.
and then you go up to the top where there's like the little, where it says number, that area, and click on where it has the arrow and the decimal point. Like if you
Add another decimal in there.
it'll move it over so that you can see another decimal, like an extra space.
Mm-hmm.
And the number that comes up is a 9, which means that we should be rounding up.
Okay. Thank you.
You just click on that little right arrow and then it shows more.
Yeah, you can click. So the one that points right shows less, and the one that shows points.
I say, yeah, you can just play with it for a second, Melody.
That's awesome.
You need to take an Excel class. I hope you take it next because it's awesome. You're going to love Excel.
Yeah. Okay. So question 24, should you reject HR or not? So I write no. No, the p-value is greater than 0.05.
Yeah.
But is that? No, the p-value is greater. Yeah.
You see D. Letter D.
D. Yeah.
If there were letters.
It's for letters, exactly.
Yeah. Question 25. What do you conclude based on your results? I conclude that we reject, yeah?
Because let's see.
We-
On this it says,
Don't reject the null.
We reject it or no? I just forgot. Okay.
yeah, so we failed to reject.
So we have insufficient evidence to say that, let me read the HA. being a morning or evening person is not independent of age.
Yes.
So it's the last one.
So the last one.
Boy, I really have to think about those.
I know.
I know. I have to write it down
there
every
and I have to
time. I have it
read it.
written down on my thing.
Every single
Especially
word.
now, the way they're asking it, you're like, wait, what?
Okay, information. Use the following information to answer the next 8 questions. A recent book noted that only 20% of all investment managers outperform the Dow Jones Industrial Average over a 5-year period. A random sample of 200 investment managers that had graduated from one of the top 10 business programs in the country were followed over a 5-year period. 50 of these outperformed the Dow Jones Industrial Average. Let P be the true proportion of investment managers who graduated from one of the top 10 business programs who outperformed the Dow Jones over a 5-year period. Information. Based on the results of the sample, create a 95% confidence interval of P. Input the lower and upper bound below rounded to 3 decimal places. So that is question
23?
Okay. So the lower was 0.190.
Uh-huh.
And the upper 0.310.
Perfect.
And then 28. Suppose you had been in charge of designing the study, what sample size would be needed to construct a margin of error of 2% with 90% confidence? Use the prior estimate of P, 0.2 for this estimate. I forgot the formula.
This one,
It's
again, I didn't know how to do.
Yeah.
I have the formula, and it's just not working for me.
What is the formula? I mean, I'm sure I have it written down. I just don't know which one.
So I had N equals the,
Okay, do you see my screen?
hold on.
Oh,
Let me-
let me go on it. Hold up.
It's this one right here.
Okay, I see your screen.
Okay,
You're
hold
giving
on.
us that.
Wait. Ah. Can I see you?
Can you see me now? Sometimes I have to talk in order for you to
No.
see me.
No,
There we go. Okay, I can see it. So what are we looking at?
So you're looking at this one right here. Let me see if I can highlight it real fast. Help you out.
Okay, I'm just gonna copy it.
For N. Yeah,
Because
that's what I wrote.
that's what we're doing, right? And so what
Yeah.
you need to do is this is the formula right here. Okay. And so I have this all input because it's a 95% confident. So I have it all input, so it's calculated it for me.
Oh, so your Z,
And that's
you
the
didn't
answer
take
we
the
get.
Z from the spreadsheet, you take the 1.768? You write above.
The Z,
Can I copy your formula? So this is
So the Z is the number
one-
that depends on the confidence interval. It's like the whole
You got it. That
95%
should
equals
be-
1.96 kind of thing, right?
yay! You got it. You got it.
Good.
So we don't want the Z above. We have to always, for 95% confidence, we always have to use the Z for 1.96.
Yeah.
Hold on, I'm gonna screenshot your,
Well, and like I said, I can email this to you. If you're going to take it right after, I'll email it to you so you have what I've got.
I can't screenshot it.
oh, please, thank you.
It's not letting me screen.
But so what was your answer for that one? Because I didn't.
So it should be, if we always round up, so it should be 1,537 people.
1,537.
Yes. Okay, real quick, when I send this, guys, to you, you notice how they color the input cells? Like over here, they're purple.
Mhm.
So the blue ones are the ones you need to input in. And real quick,
Yeah.
my Z, so you know, these Z numbers all over here, these Z stars, are connected to this purple one right here. 5%
Okay.
confidence interval, just put the 95% confidence interval up there.
Okay.
And like, so right now, if I change this to 99, automatically changed. And if I put it to 90, my Z scores automatically change.
Oh,
Okay.
So it's connected right here.
But you have to introduce the M and the P
The M and the P. Which one?
when you
Yeah.
have solved for N, then you have No, like down the. You need to go down. To
Oh,
scroll
down.
down.
Okay.
Yeah.
So
Then
this
you
one
have solve
is-
for n. You have a C, and then you have an M and a P.
So this is for the margin of error when they tell us to calculate margin of error. And that's why every single time I do this, it gets wrong from what this is, my margin of error over here. So it drives me crazy that it gets it wrong every time. So I just do the one that we've been doing where I do the one and the other and divide it by the 2.
That's what I've been doing because the other
Okay. But can you give me the n formula? I just want to have it written.
You want
So it was C
which
times
n
something.
formula? You want the solve n
Yeah, that
one?
one. Yeah.
This one right
I
here?
can- yeah, the n. Yeah. C
And the p is
times
unknown,
something.
right?
Okay.
Let me see.
Okay. Just let me
Work?
see. Yes, thank you. So the thing that is over the n, that was like the I don't know the name today. the I don't know how to ask. Okay, thank you.
Okay, and real quick, you're also going to see something I added on here. It always asks occasionally if the hypothesis test, if the test statistics are right? Because they're supposed to be equal or above 10. These right now, they turn green if they are equal to or above 10. If they aren't, they're going to turn red, just so you know.
Oh, fancy.
I know. I love my Excel class. I've learned on so many fancy things.
When do we,
Okay, are we ready to?
oh, that's just the confidence. That's just, this is my question. Which one is the hypothesis and which one was the confidence for the green things?
for the
Wasn't there
green?
something that you test for if you're doing the hypothesis
yes.
versus
So,
confidence?
and on this one, on this test of one proportion, it's both. See, it says the hypothesis test requirements for both P is equal to or greater than 10.
Oh,
And
hypothesis.
this one's,
P.
and that's the hypothesis test. And here's the confidence room, which is the N with the P hat, right?
Okay, that makes sense.
Does that make sense?
Okay.
I went ahead and put the formulas down there so I'd understand what it was trying to do.
Okay.
Everyone good? Are we ready to go on to the next question?
Yeah, I'm
Yep.
good.
Yep. Okay. Okay. Information. Suppose you wish to see if there is evidence that graduates of one of the top 10 business programs performs better than other investment managers. Conduct a hypothesis test. Use a level of significance of 0.05. Which of the following pairs of hypotheses is the most appropriate for addressing the question? So I got, let me see which one, greater than
Sorry,
the
guys, I'm behind.
A, B, C, D,
We're on
E.
problem. What problem? 28.
29?
What was the answer for 28?
29.
No, but what was 28's answer? Write it down.
Oh,
1,537.
Oh, that one. Okay. All right, now 29.
Okay, so I forgot HO, but that's not the way it says. P, they are supposed to say P equals 0.2, and the other one, P is greater than 0.2.
That's what I have. Which is the
E?
second to last one.
Yeah.
yes, I think you're right.
Okay, and then what requirement? I don't know what's happening. What requirements must be met to ensure that P hat is normally distributed? The first one.
Yes.
Yes.
So I think.
What is
Which one is it that we use a
on top
5?
of it?
Sorry.
Which one is
So-
it that we use a 5?
The 5 is the last one. The chi square or chi
Okay.
square.
Okay, that's right.
Okay. So question 31. The value of your test statistic is, I think if it's 27, it's 1.768.
Yep, that's what I got.
Okay. So 32, the p-value of your test is 0.039.
Yep.
And is there sufficient evidence to conclude that graduates from the top 10 business programs perform better than other investment managers? I say yes, I reject HO.
Yep.
So the first one?
Mm-hmm.
Yes.
This is exhausting for me.
It's so exhausting. I can't believe you're going to try and take, I just need a break to break. Can't believe you're going to try and take the quiz after this. Okay, you ready? I'll take the next group.
Maybe I'll take a 30-minute break, but
Yeah, you might want to just
Just let everything soak
wait
in.
until you get the email from me, right? For sure.
yeah, that's a good idea.
Okay, so for the next one, everyone got, do I need to read that first paragraph, or does everyone understand what it's
No,
doing?
please don't.
So to
Good.
compare the Pharaoh's ability to translate with similar computer translation, Cohen took a random sample of 100 blocks of Spanish text, each with which contained 300 sentences, and used Pharaoh to translate each of these to English. The blue scores are attached, so I guess we need to open the blue scores now. These scores are recorded in the data file. He wants to use this data to see his mean blue scores differ from the blue score of another leading translation software, which has a population mean score of 0.295. So assuming the requirements are satisfied, construct a 95% confidence interval of Pharaoh's true mean blue scores. Okay, so I felt like I've done so many things. That was 23.
31. 30.
Is that your friend?
What?
And they're with you right now, Melody?
No, I pick her up at dark 100 in the morning.
Oh. Come on. Uh-oh. Okay, so I got the lower confidence interval of 0.282.
Yeah, me too.
Perfect.
And I have the upper bound of 0.293.
Mm-hmm.
It wants us to calculate the degrees of freedom with the test statistic and gives us the null and alternative hypothesis. Assumes the clients are satisfied. Input your answers for the next 3 questions. So the degrees of freedom should be 99.
Yeah.
Yeah.
Mm-hmm.
And the test statistic is the t-test. And I have a negative 2.803.
Mm-hmm.
And then question 30, to input your p-value rounded into the 3 decimal places. So I have 0.006.
Yeah.
Yeah.
Mm-hmm.
And then question 3, based on the results, what would you conclude? Use a level of significance of 0.5. So we have sufficient evidence to say that the true mean is different than 0.25. We have
Okay.
sufficient evidence.
Yes.
So it should be A, the first one.
Yes. Every time I read those
Okay.
questions, I really have to read them.
I do. And double check. All right, what is this? Okay. Anyway, okay, now we're going to AM, PM, heights. Woohoo. And they would do that. And we have a level, we want to construct a 95% confidence interval for the true mean difference of heights and conduct a hypothesis test with a level of significance of 0.05. Determine if the children are taller in the morning than in the evening. Input your answers below. So, so my lower input is 8.728.
Yeah.
Mm-hmm.
Got that. Okay. And my upper was 10.455.
So let me just stop you for a second. So if it had asked us for a 95% margin of error for the confidence interval, that's when I would take the 2, subtract 2, and divide by 2, right?
Yes.
You got it.
All right.
Mhm. It says input the test statistics for this test. My test statistics was 22.446.
Yeah.
Is that what you guys got? I was like, wait, that can't be right. It's too big of a number, but it's
I know, that's same. That's
threw
exactly
me
what I
off for a
thought.
second. Degrees of freedom should be 40.
Yep.
Mm-hmm.
Okay. My p-value was 0.00000.
Oh, really?
Yeah.
Yeah.
It actually is, it's supposed to be 1.E397, but it's e to the negative 24 is the p-value that I got.
The decimal place over a million times.
Oh, I had one written down, but maybe I just wrote it down wrong. When I don't know.
So the p-value is less than, so we would reject the null, so we should have sufficient evidence. So it says, based on the result of your test, is there enough evidence to suggest that children are taller in the morning than in the evening? And I said yes, because we rejected the null.
Yeah. So C. In number 44, if you got 1 is because you wrote less than instead of greater than.
Maybe.
And the
Define
type of test. If you change the type of test, that changes.
Let me look, just for fun.
Okay. Am I okay to submit this? Should I try? I'm totally nervous. This is just a quiz and I'm totally nervous to submit it. I have a feeling we're going to get some of them wrong at that beginning one. I'm not very confident with that.
You're right, I put.
I'm never confident.
Oh
with
my
this.
goodness, we only got 1 wrong. We got 42 out of 43. Holy cow.
Yes.
Which one?
Yeah, wait, which one?
Oh, did I click the wrong one? So for number 45 that we just did, oh, I have to put no because we rejected null. It should be yes because we rejected the null.
Yeah.
Is that what you guys put? Yes because we rejected null? I clicked no because we rejected the null.
Oh, so technically we got 100%.
So anyway, you guys got 100%. I can't. Now I have to input all those stupid answers.
I just have a question.
Uh-huh.
Number 3. What did you put in that one?
Okay, so for number 3, I put. So for number 3, I did the test of 2 proportions.
Okay. Okay. So I'll
Any
submit.
others you want me to go over those first 8
I think that's the only one that we had.
that we really debated over?
Yeah.
Yeah.
Okay. And then real quick, do you want to stop the recording and we'll talk about the project for a second?
Oh, yeah, good idea.
So I realize you don't even have to turn this recording in. But I have it. If you guys want it, I can email it to you.
That always happens to us. But that's okay.
That's okay.
But yeah,
Doesn't really